Hello everyone, my name is Roshni and welcome to our group's presentation on our AutoML prototype for predicting patient readmission risk at BR Hospital. Our team consists of 5 people: Suyog Shrestha, Roshan Khatri, Yogesh and Ola along with myself. Today we'll share how we used MLJAR AutoML to tackle this healthcare challenge, building on our previous assignments, Assignment 1 and Assignment 2. Our data comes from a simulated EHR dataset inspired by reputable sources like Kaggle's Hospital Readmission dataset, which also ensures the credibility of our dataset. Let's dive in further. I will handle it over to my colleague Roshan.
This is Roshan Khatri, and I will be talking about the problem statement and the objective. Firstly, we open hospital readmission for like major challenges in increasing the healthcare cost, and impacting patient outcome. So our main goal was to predict patient readmission within the 30-day using machine learning. So initially we relied on manual resemblance model like random forest gradient boosting using like diverse electronic health control such as clinical demographic or like social economic data. So while this approach shows potential, we had three major limitations. That is like it didn't integrate well in the hospital workflows, and it lacked measurable goals beyond the basic prediction accuracy, and it also like required manual tuning, make it like difficult to like scale for like real world hospital use. So for that we redefine approaches using auto machine learning. So to address this issue, we adopted MLJAR AutoML, which is an automated machine learning framework. This shift allowed us to move from manually tweaking the model to like fully automated scalable solution. So with AutoML, we achieved three major improvement, like early identification of high risk patient, enabling timely intervention and better resources allocation, and automation eliminate the need of the manual hyperparameter tuning and make a deployment a lot easier. And a comprehensive and structured approach was defined, like who is the be hospital patient and staff, what is the risk prediction for the hospital readmission, and when the patient should be like pre-discharge or shortly after like being hospitalized. So we have done the evaluation performance using automated in the notebook as well. I will show you that. So this evaluation console, like by adopting AutoML, we improve prediction accuracy, efficiency and scalability, making it like practical solution for real world hospital deployment. This redefined on our approach a strong evaluation score of 9 out of 10, highlighting its effectiveness and impact. So as well, like we our approach was also supported by like various research studies and articles on the machine learning in healthcare. For this, like there are like sources highlighted and effectiveness of AutoML in improving predictive accuracy and decision making, refining our shift from like manual modeling to automation. Thank you, Professor.
Hello, Professor. This is Suyog, and I'm going to walk you through the machine learning pipeline, which is designed to predict hospital readmission. The first part, we are using the AutoML approach and leveraging MLJAR AutoML path for this purpose. So, AutoML or MLJAR is used to automate model selection, hyperparameter tuning, and evaluation. So first of all, we have used the AutoML from supervised.automl. So this is the MLJAR AutoML tool for model training and selection. First of all, we load the dataset. So just quickly going through the dataset, since we've worked on a hypothetical situation, we have generated the data using a script. So we have all the numerical data, categorical data here, and also we have embedded a signal for readmission based on age and lengthy stay. So for example, higher and longer length of stay increases the probability of the readmission, and we have also created a linear combination to compute probability. So this is done to simulate a realistic scenario. So we have created feature columns like based on category. So clinical, demographic, socioeconomic, and historical category are there in the data. And our target would be readmission. And first of all, we go ahead and train test split from the data set. So train test is 80 to 20%. Once that's done, we also define the result path. And in AutoML, while calling the AutoML function or class, we have used the mode as perform. This is used for balance mode for good performance. And AUC, also known as area under the curve, is used for imbalanced data sets. And the total time limit is 1 hour. This is to prevent the excessive computation. So we have limited resources, so we just kept an hour of total time limit. And the result path is a directory to store the trained models. So this model will try with multiple algorithms, namely random forest, light GBM, XGBoost, and automatically tune hyperparameters. And once that's done, we predict probabilities and a class label on the test set. So the ypred underscore prob A is probability of readmission, and also ypred is the actual predicted class. Once that's done, we evaluate the model. So ROC, this function is used to measure how well the model separates readmitted versus non-readmitted patient, and accuracy is percentage of correct prediction. And the classification report, so this is a general report that has precision, recall, and F1 score that we can also see in the result. So result has the test AUC has 0.84, which is around 84%. Test accuracy comes around 79% here. And classification report is as follows. And once the report is finalized, the model is also saved to the MLJAR readmission. So if you see here, MLJAR readmission has all of the tried model from the AutoML class. So these are the tried algorithms, and there are all of the stats here. So AutoML does this automatically.
Hi, Prof. My name is Olasiu, and this is the machine learning prediction and outcomes. We built a simple model manually using random forest and gradient boostings. These models are great for predicting hospital readmissions because they handle complex data and things like patient history, clinical conditions, and even socioeconomic details. They gave us a good result of that's AUC of 0.819 and 75% accuracy. So for assignment 2, we switched to MLJAR AutoML, which automated most of the heavy lifting, such as processing, model selection, and tuning. So the results were better. The AUC jumped to 0.848, and the accuracy rose to 79%. So for the code part, we loaded the trained MLJAR model using AutoML.load to make sure it worked as expected, and we read a file of 500 new patient records, pulled out the future columns and RAM predictions. Also, we used .predict to get class labels, meaning whether each patient is likely to be readmitted, and predict prober gave us the actual probability scores. Also, finally, we added those results to a data frame and saved them into a CSV file called new data prediction .csv, which could be used for real hospital decision making. So this process improved performance, but it also made it easy to scale and apply in reward settings like Bear Hospital. Thank you, Professor.
I'm Yogesh Neupane, and I'll be walking you through the key results, discussion points, and future direction of our project on patient readmission prediction using MLJAR AutoML. So our goal was to predict patient readmission within 30 days using historical EHR data. We tested multiple machine learning models, example like Random Forest, XBoost, and AutoML for this second
approach. The best performing model was MLJAR AutoML, which achieved 90% accuracy, 87% precision, and 83% recall, outperforming all our previous manually tuned models. So key features influencing readmission included past readmission lab results and patient's age. Our feature importance analysis showed that our prior hospitalization had the highest impact, which aligns with medical intuition. Patients with history of readmissions are at greater risk of returning. The AUC ROC further shows that our model had strong predictive capability, making it a promising tool for real world applications. With these results, while these results are promising, there are few challenges to consider. First is a data bias. Since our dataset comes from a single hospital, and the model might not generalize well to other healthcare settings. And the second is ethical concern. Using AI in medical decision making raises questions about transparency and fairness. And third is real world deployment challenges. So hospital need proper infrastructure to integrate a predictive model into their workflows. Despite these limitations, our model provides a valuable insight for hospital administrators. By identifying high risk patients early, hospital can allocate resources more efficiently, reducing preventable readmission and improving patient care. Moving forward, we aim to enhance the model by incorporating real-time patient monitoring data to improve prediction accuracy. We also plan to use SHAP values to make the model decision more interpretable for healthcare professionals. And additionally, a pilot implementation in a real hospital setting would allow us to test model effectiveness in practical scenarios. We are also exploring fairness and bias mitigation techniques to ensure that AI driven healthcare solutions are ethical and inclusive. So, in conclusion, predictive analytics in healthcare has the potential to save lives, reduce costs, and improve hospital efficiency. So, this our project is a step toward achieving these goals. Thank you for your time, and we would love to hear feedback from you on this assignment. So, these are the references for our project. That's all. Thank you for the time.